Hello everyone, this is David Cuartiellas, co-founder of Arduino, transmitting live from the coldest shed in the universe. It is probably 10 degrees in here. We haven't started heating the shed for a month, more or less. We went for Christmas and we haven't been in for a while. Today I actually have a friend that came all the way from Mexico, so say hello to Andres. Woo! Andres is one of the collaborators with one of our great developers, um, Sandeep, and he's collaborating together with Wero and some other people with the LoRa libraries for the Arduino Maker family. Today is about the Maker family I want to talk because we want to make an experiment with the Maker 1010. Let me show you how it looks like. Woo! Super nice. Yeah. So as you know, the Maker 1010 is having both Wi-Fi and Bluetooth as a possibility for connectivity, and it was with the SAMD21, can run on a battery and can be programmed through that beautiful micro USB port. And the thing is that it has a lot of nice libraries inside, and I really would like to make something nice with it and doing something like this. Oh, it's a bit. So I want to connect it to a screen and I want to connect to some buttons. So at the end of the day, what I want to do is a calendar. I want to make a clock/calendar that will be listing events, and that's why this livecast is called the Space Calendar. Today, this year, 2019, is the 50th anniversary of the moon landing. So a couple of brave men made it to the space and managed to place a flag. Even though it's the United States flag, it could be anyone's flag. I think they represent all of us. And we at Arduino have decided that we want to celebrate the space year by making a whole series of events around this topic. So I thought, what if we list all of these events in a calendar? And what if we make a calendar that will connect to the internet and update itself? So in a series of 2 livecasts, I will show you how to make a calendar. Today I will just focus on the very basic underlying software that you need to run on the Maker 1010 to both run the screen, connect to an online clock system, and start internal real-time clock. And finally, if we have the time, we will see how to parse JSON strings, or at least how to get JSON strings. If not, that will be coming in the next livecast. So, where to start? So we're going to be using today, as I said, the Maker 1010, and we're going to be connecting it to a breadboard, to a screen. There will be a couple of buttons, even though today we will not see anything with the buttons, and some wires. And this is everything you need in order to build a not so complicated circuit that will let you get data from the internet and show it on the screen. And I will focus on a couple of nice tricks that I did in code, the code that, by the way, we will share later tonight on the Arduino Livecast GitHub account. So let's get started. Let's get started by looking at this circuit and the kind of code that you could use to work with it. So the first thing I will look at is an example that we like to call WiFi RTC. And the idea of WiFi RTC is that you could build a Wi-Fi network, connect to a Wi-Fi network with your board, and you could get the time from the internet and displaying it somehow. So this example here is based in one of the basic examples from Arduino, and it's using, first of all, the Wi-Fi Nina library, which is the library that is used to control the module and connect to the internet. And it's using this very nice RTC Zero library that allows you to use the internal registers on the SAMD21 as an RTC clock. So once we get the time from the internet, we use that as a reference, and from that moment on, our board will start ticking at real time as a real-time clock. Of course, if it runs out of batteries, it will lose the time, but the idea is that it will always be connected to something, and as soon as it runs out of batteries, it will also disconnect from the internet, so it will make no sense to have it anyway. So we're using the Arduino secrets file here. For those of you that don't know what this is, the Arduino secrets file is another tab that I will not tick on that contains the SSID and the password to that network that is my home network. So I mean, if you come by Malmo, I will let you connect to my network anyway, but I will not post this on the internet. I learned the hard way because once I share my phone number. So this information is taken from the Arduino secrets tab, loaded in here, and everything that we see here is used to turn on the Wi-Fi connection. I will not go in depth into everything, but this is code. This code is inherited from the code that we had earlier on the Wi-Fi shield for Arduino Uno and Arduino Mega, and therefore some of the functions are working in a similar way. For example, Wi-Fi status no shield means, oh, there is no connectivity. Obviously, there is no shield on a maker board. It basically means that the connectivity on Wi-Fi is not working. So even though you have the library, you might not have the right board. You might have taken your wrong board from your box. Once it's connected to the basic network, it will try to establish a proper connection using the password. And in this case, we're going to connect to a WPA2 network, and it will send the SSID and password up over the Wi-Fi and be identified. Once it connects, it prints out the status, and still in the setup, we start the RTC clock. So we start ticking at the time for the internal clock, sorry. And we declare a variable called epoch that we were going to use to get the time from the Wi-Fi. So this function will connect to the Wi-Fi, get the time. It will try a couple of times. And if it can make it, it will just tell you that the server you try to connect is unreachable. But if it gets it, it will start printing out the time all the time. That's what it does in the loop: print date and print time. Print time is a function that just gets the time, it extracts the hours from the time, extracts the minutes from the time, and the seconds from the time, and prints them out. And get date does the same thing with date information. So if everything works as expected, the thing you're gonna see is actually this. And here you see how the time is ticking. I prepared, oh, sorry, you don't see it yet because I have to change to this view. So here you see how the time is ticking on the serial port monitor. So far we're not really doing anything with the screen like connected there. As you saw in the code, I'm just focusing on the basic aspects that have to do with connectivity and getting in data. And the reason for me making the example this way is because I would like you guys to repeat this, and I'm giving you the things step by step. So today I'm going to show you 3 different programs, and we will share those programs with you so you can download them and use them on your own. So you see how the time keeps on ticking, and right now is 8:27 and 18 seconds in Sweden on the 29th of January of 2019. So it's pretty straightforward. It's quite easy to use. The code on the Wi-Fi might not be evident at first, but once you start using it, you realize that actually it's pretty straightforward. And the complexity between this example and the next example is it jumps a bit. So what we're going to do next is to, let's open the next example. Sorry, it's up here. I will open it and then put it to load because it takes some time until it loads. We have here LiveCast 3, and we made a revised version of the code. And it opened on a different window, so I have to bring it to you. 1 second. Here we go. So in this revised version of the code, I just clean it up so it becomes easier to work with it. So right now, config network is in this functions tab and contains all of the configuration network information. So this is a second step in making this work. And I like to, as I evolve writing code, as the code grows, I like to start to package it in functions and remove it from the view so I can focus just on working on the setup and the loop, which is what at the end people are gonna be seeing. So I'm gonna just change the view for a second, so you can see me. You don't see how I change the login and password in this example, just to prove that it works like the previous one. So I type in the password now. Okay. So I can change back to the IDE. So I just changed the password on the Arduino secrets tab, so you couldn't see my password, and I upload it to the board. And once it's uploaded, this one's still not using the screen. It's just that it's doing the exact same thing as before, just a little bit cleaner. I just want to show you that it's possible to write clean code and still makes sense. So right now it's just finished uploading. We open the serial port monitor and we wait to see how it works when it connects. Sometimes it doesn't connect at first and it makes a couple of attempts to connect to the network. Sometimes it connects just directly. And as you know, with the internet is like this. Well, we managed to connect right away, and you see my network is actually called Quetzalcoatl, which is a Mexican god, right? So we have Mexicans home today in the shed. It could be considered the god of Wi-Fi because it's a snake with feathers that flies around and makes a mess. But anyway, you see the code works perfectly. So the next step is bringing this to the tiny screen that we have here. So instead of showing things on the serial port monitor, we want to show things on that thing there. And the next example of code I'm going to show you is a lot messier. It's a lot messier. And this is a thing that I will explain now, but I again invite you people to try out on your own once you have an hour or so to look at it, and is making use of the screen. So here we go, the example with the screen, and again the introduction to the code is exact same. Here we're gonna add some code by our friend Limor from Adafruit, which is the one that controls the screen. The one particularity of the screen here is that it's not a very fast screen, and so it's actually kind of hard to refresh it all the time. If you have a clock, you want to be changing digits all the time because the seconds are ticking. And so what this code does is to take a look at the screen and refresh only the part that is actually changing and not changing the rest of the screen. That's a very nice trick that I inherited from my times programming Commodore 64. Kind of like a sprite on the screen. That's the number, and I only change the number that changes. I will show you how this works. So first, we have here the libraries for the screen that we take from Adafruit, and these are the pins where we connected this TFT screen. This TFT screen that I have here is very nice because it also happens to have a touch screen, but I haven't implemented it at this point just yet. But maybe we might come to that later in a later livecast. And when I work with systems like these ones, I like to use different work modes. I always build kind of state machines that allow me to check that things work properly over the serial port and get data reports on the serial port. So I created a couple of variables here that I call both serial and screen, so I can monitor the data both through the normal screen, which means the screen connected to Arduino now, and through the serial port monitor. In this particular case, I'm going to be working with both, so we'll see data coming on both places. Well, this is the serial port communication, sorry, the Wi-Fi communication information, and I'm going to have a timer. And look at this, I'm going to have two variables to store the time, not the date, just the time. And the time is going to be changing every second. And when it changes, it will change one of these numbers. So there's three numbers, one for hours, one for minutes, and one for seconds. And the idea is that I need to have this if I want to be changing just the part of the screen that is changing for real and not the whole screen at once, because I will take some time to refresh the whole screen. This thing is going to connect to a server. Actually, I made it connect to my personal server, and it's going to try to download the website from my server to show it up here. And the reason for this is that in the long run, what I want is to connect to a server to download a JSON stream that will contain information about the calendar. And that information for the calendar is the thing that will be shown on my screen. For example, moon landing for the space year is July 20th. So there, for example, I don't know how many days there are until July 20th, but probably it's like almost 5 months. So 6 months times 30 days is 180 days. So my calendar is going to tell me later how many days there are left until the next event that will be downloaded from the internet. So I need to connect to the internet to download this data. Today, we're just going to see how we connect to the internet and get that data and show it on the screen. And in later livecast, we will see how we get that data and calculate the next day and show even an image on it. So the next code is all about configuring the display. And the same way I made a config Wi-Fi function, I made a config display function that I have in the functions tab. And here you can see the code that what it does is sending all of the different values that are needed for the screen to be configured. And then it also prints out whether the configuration process went okay. So it's not rocket science, and it's taken from a default example from Adafruit, and I just use it here. Then we start by filling the screen in black. We configure the network. We configure the RTC, and we fill the screen in black again after 5 seconds and start counting the time. We get the current time. Getting current time goes to the RTC, gets the actual time right now, and if the time has changed, which is what is different does, then it displays the time. And displaying the time means that it's going to be changing on the screen only the tiny bit that changes, which is the seconds. If the seconds come to an end, then it will also change the minutes. And you will see how the refresh time on the screen changes from refreshing just one number to refreshing 2 numbers to refreshing 3 numbers at the same time. It also tries to connect to the internet, and if the client, which is the connection to the internet, it's getting data, you will just download the data and print it on the serial port and on the screen. And every X amount of time tries to connect to the internet and reprints the information on the screen once more. So it's pretty straightforward. At the end, it copies the time. What it does is takes current time and puts it into previous time to be able to compute the difference every time the loop runs. Inside the functions tab, we see that there is a couple of functions, which one of them is print time, and print time, depending on the variables we chose, will print the time on the serial port and or the screen. Another function here, delete time. Delete time actually checks which is the time we need to change. So if we need to change the seconds, it will just delete the seconds so we can print the seconds on top. So it takes some data about which is the digit that we are going to change and uses that in order to change that on the screen. I have to say, this is I think this code can get very handy for you if you do other projects, because if you want to use screens and you want to use data that changes all the time, like a clock ticking, refreshing the full screen just to change the clock will make your whole interaction super slow. So I think the real contribution of this LiveCast is that very, very tiny piece of code that is going to be changing the screen at a different speed. Then printing date is just printing the data both on the serial port or the screen. And the rest is Wi-Fi status information and functions that are used to control different small things. Finally, here we have, I'm making a test HTML for the calendar. It's not the calendar that I will be reading later on. The calendar I will be reading later on will be connecting to a PHP file that will be going to a database that will be getting the next event in time and downloading that to your clock. But right now, that's not the thing that we're displaying. We're just looking at how to show time. So, but this will just connect to this website that is on my server and just show it and just see that it basically works to connect. So we're going to see the date, we're going to see the time ticking, and a website is going to be downloaded every now and then. Okay, so I will take away the screen again because I need to change the parameters on the Arduino secrets tab so that you don't see my data here and the password. Here you go. I upload the code, and you can see that I will upload the code to the board. And it's going to be a lot of fun because now we're going to see at the same time how data is being changed. Oh, I have to see this. This is an error because clearly I didn't try this example on my streaming laptop. I tried it on my personal laptop. So I'm lacking this Adafruit library. So I will just look for it and install it live. So this is actually a proof that this thing, I made it myself, basically. So I go to the library administrator in Arduino, and I think we have to add the Adafruit graphics library and this one as well. So we install this one, and we need to install the Adafruit graphics library. And GFX. No, I have it installed. So I was only lacking the library for this particular display. So let's see if now it compiles. Oops, another error. Very interesting. Let's see what I did. Oh, I'm lacking the TFT library. Fatal error. SPI TFT. So I'm lacking yet another library. So I go to libraries. And I look again for it. To say it's so cold in my shed that I can barely type right now. Whoops. Something I did wrong. GFX. See if I have the latest version. Oh, maybe I don't have the latest version of the library. And that might be the reason why. I think now it should be no problem. Water tension, 10, 10, 10, 10, 10, 10. And yes, so I just had to update the graphics library, that was all. So just to remind you, what we have now is we have an Arduino MKR1010, which has Wi-Fi and Bluetooth. We're connecting through Wi-Fi to the internet, and we are getting an NTP server that gives us the time. And with that, we are, you see here, the screen is changing, it's getting data. We're getting the time from the server, and we are posting this both on the serial port and on this tiny screen. Right now you see on the serial port monitor, you see that it says a date, and then it says colon, colon, and then the seconds. So the program is detecting that only the seconds change, and that's what you see printed there. The moment there is a change in the seconds and shifts to the next minute, it also prints how the minutes change. And then there's always a second line that is printing out the full time, right? But it's the full time that's taken from a different server. Sorry, no, it's the right time. I know what I'm saying. And now he has connected and managed to download the website. So let's just take a look at this view, and I will just bring down the camera for a second. And you see the screen, you see the date, and you see how the only thing that is blinking a little bit is the seconds. It's the only part of the screen that is actually being changed live right now. The rest of the screen is being kept untouched until there is a new load of the website that is every certain amount of time. And then at that time, then the whole text will be printed again. So with a couple of very simple tricks, you can start using screens, real-time clocks, Wi-Fi, all at the same time, and build your own clock. Today we saw how to build a very tiny clock that connects to the internet and can download some data. Our goal is going to be making this super nice, so it connects to a server that will send you a JSON stream, and from the JSON we will get data that will help us to establish when is the next event on the Arduino space here. So this is what I wanted to show you today. Our first step towards building our own calendar. As you saw, it's a pretty long process. So I just wanted to show you the state of the art of the technology and the state of my proof of concept. And I think that very soon, in a week or so, we will be done with this. So thank you very much, everybody, for watching. We'll see you on the internet. And well, thanks to Andres again for being here, considering how cold it actually is. He came all the way from Mexico just to be, well, not just here today, but to do other things. But yeah, I'm really thankful that he managed to come. So thank you, everybody, and see you next week on the Arduino LiveCast series.